Have you ever seen the sky just go dark in the middle of the day? It's one of the most incredible things you can ever witness. Today, we're going to pull back the curtain on how this amazing celestial event actually works. So let's dive in.
I mean, just look at this. It's a cosmic dance that has fascinated people for all of history. You see the sun, our constant, everyday star, slowly getting covered up piece by piece. And then, for just a few minutes, it reveals its stunning outer atmosphere, the corona. This is a huge deal for scientists because it's pretty much the only time they can study this super hot layer of plasma right from here on Earth.
So what is actually going on? Is the sun really vanishing? Well, of course not. What we're seeing is a perfect but very temporary alignment of cosmic bodies. Really, the best way to understand an eclipse is to think of it as a giant shadow play. It's not so much about the sun itself, but about the shadows being cast across the solar system.
And at its core, the definition is super simple. An eclipse is just when one object out in space blocks our view of another. It could be a moon blocking a sun, a planet blocking a star. It's all about being in the right place at the exact right time.
And this right here, this diagram, is the key to everything. You see, a shadow in space isn't just one big blob of darkness. It has two parts, a really dark inner part, the umbra, and a lighter outer part, the penumbra. Once you get these two, you'll understand all the different kinds of eclipses.
First up is the umbra. Think of it like the bullseye of the shadow. It's the very darkest, most direct part. If you happen to be standing on Earth right in the middle of the moon's umbra, congratulations! The sun is completely blocked. You're experiencing a total eclipse.
But then you have the penumbra. This is the fuzzier, not so dark part of the shadow that surrounds the umbra. If you're in the penumbra, you'll still see an eclipse, but it'll be a partial one. You'll see a bite taken out of the sun, but not the whole thing.
All right, so let's get to the big one, the main event that everybody talks about, the one that can turn a bright sunny day into a strange twilight, the solar eclipse.
So for a solar eclipse, you need this very specific lineup: the sun, then the moon, then the Earth, all in a perfectly straight line. You know, it's an incredible cosmic coincidence that our little moon is just the right size and just the right distance away to appear to perfectly cover the gigantic sun from our point of view.
But it's not always so perfect. Not all solar eclipses are created equal. There are actually two main types you can see: a total eclipse and something called an annular eclipse.
And wow, you can really see the difference here, can't you? On one side, you have that breathtaking total eclipse, complete darkness. But on the other, you have this incredible ring of fire. The moon is right in the center, but it doesn't quite cover the whole sun, leaving that fiery halo. So why the difference?
Well, it all comes down to the fact that the moon's orbit isn't a perfect circle. Sometimes it's a little closer to us, and sometimes it's a little farther away. When a solar eclipse happens while the moon is at one of its farthest points, it looks just a tiny bit smaller in our sky, too small to completely cover the sun. And that's when you get that amazing ring of fire.
Okay, so that's what happens when the moon casts its shadow on us. But what happens when we flip the script? What happens when our own planet, Earth, casts its shadow on the moon? Well, that's when you get a lunar eclipse.
For a lunar eclipse, the alignment is totally different. Now it's the sun, then the Earth, then the moon. Our whole planet gets in the way, casting this huge shadow out into space, and the full moon sails right into it.
But the moon doesn't just go black. Instead, it often glows with this incredible, deep, rusty red color. People call it a blood moon, and the reason for that color is just amazing. It's the light from all of the sunrises and sunsets happening on Earth, all at once, filtering through our atmosphere and being projected onto the moon's surface. Think about that. You're seeing our own planet's glow, lighting up the moon.
Okay, so we've covered a lot. Solar, lunar, let's do a quick side-by-side comparison just to make sure it all clicks.
This chart lays it all out nice and simple. For a solar eclipse, the order is sun, moon, Earth. The sun gets blocked and only a very small part of the world gets to see it. For a lunar eclipse, the order is sun, Earth, moon. The moon gets blocked, and basically anyone on the night side of the planet can look up and watch the whole thing unfold. So now you know what they are and how they work. Which brings us to the most important question, right? How can you actually see one of these for yourself?
If you want to see a total solar eclipse, there's one rule: location, location, location. You have to be inside this very narrow strip called the path of totality. That's where the moon's darkest shadow, the umbra, will travel across the Earth. If you're outside that path, you'll only see a partial eclipse. And please, I have to say this, you can never, ever look directly at the sun without special, certified eclipse glasses. Seriously, your regular sunglasses are not safe.
And it's the exact same story for an annular eclipse. If you want to see that ring of fire, you have to be in its specific path. This map here shows the path for the one in 2023. I'm telling you, people plan their vacations years and years ahead of time just to be in the right place at the right time.
And hey, here's a little bonus for you. A similar, but way rarer event is something called a transit. This happens when a planet, usually Venus or Mercury, passes in front of the sun from our viewpoint. They're way too small to block the sun's light, but with the right equipment, you can see this perfect little black dot moving across the face of our star. Pretty cool, huh?
You know, from ancient stories trying to explain what was happening to modern science using them to make new discoveries, eclipses have always captured our imagination. They're this incredible reminder of just how grand and complex our universe is and our little place in it. It really makes you wonder, what else is out there waiting for us to find, hidden in the shadows of these cosmic giants?